Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about how you solve two equations in two unknowns. You may encounter a situation where you need to solve for two variables and there are two sets of conditions on those variables. For example, if you were asked to solve x plus y equals 30 and 2x plus 3y equals 70, you're finding a value for x and for y that work in this equation as well as this. Both of these are linear equations, which means if we were to draw them, they would just be straight lines. And if you think about what it means to solve a system of linear equations, we're basically finding the point where those two lines intersect. But we're going to do it algebraically rather than drawing them. So one way that you can solve these is to eliminate one of the variables in one of the equations. To do that, you get the same coefficient for either the x or the y, and then you add or subtract the equations depending on the signs involved. So the easiest thing for me to do in this case, because I have a 2x here, I want a 2x here, so that means I'm going to multiply the whole equation by 2. We know that we can multiply this side by 2 as well as this side by 2. So when I do that, I get 2x plus 2y equals 60. So now I'm going to use this equation and I'm going to subtract one from the other. Because 3y is larger than 2y, I'm going to take this equation and I'm going to subtract this equation. So 2x plus 2y equals 60, and I'm subtracting the whole equation, which means I'm subtracting every term. So I'm subtracting 2x, I'm subtracting 2y, and I'm subtracting 60. So 2x minus 2x is 0. 3y minus 2y is 1y. 70 minus 60 is 10. So now that I have the value for one of the variables, I simply plug that into either equation. I'll take the easiest equation right here and solve for the other variable. So I know that x plus y, where y is 10, equals 30. Solving for x, I subtract a 10 from both sides, and I get x is equal to 20. So that's the solution for that system of equations. Let's do a quick check. We know that 20 plus 10 equals 30. Let's check this equation. Does 2 times 20, which is 40, plus 3 times y, which is 10, which is 30. Does 40 plus 30 equal 70? Yes. So I know that this solution works in both equations. Let's look at another set of equations where the coefficients aren't quite so easy. In this next example, our coefficients are not as neat as in the previous example. And we have a choice whether we want to eliminate a or b. Because there's a minus here and a plus here, I'm going to choose to eliminate b, because once I get the same coefficient in both of these terms, I simply add the equations. So in order to do that, I'm going to take this equation and multiply it by 7. I'm going to take this equation and multiply it by 2.1. And then I will end up with the same coefficient for b in both equations. So when I take this equation and I multiply by 7, I get this equation. When I multiply this equation by 2.1, I get this equation. Notice that the coefficient for my b term is the same. They're opposite in signs, so I'm going to add the two equations. 24.5a plus 8.61a is 33.11a. This term is gone. When I add these two numbers, I get 248.325. Now to solve for a, I divide both sides by 33.11. And that's equal to 7.5. Now that we have a, we can plug that into either one of these equations to solve for b. So plugging 7.5 in for a in our first equation allows us to solve for b. So negative 2.1b will equal negative 5.85. Divide both sides by negative 2.1. b is equal to 2.7857. Let's take a look at a practical application of where you might have two equations and two unknowns and you're asked to solve it. So the question says the price of admission to the movies is $13 for adults and $7 for children. The total revenue for one day is $3,125. The total number of attendees for that day was 275. How many children and how many adults attended? So this is an equation where we have two things that we don't know. And in order to solve a problem where we have two unknowns, we need two equations. So let's look at the problem and see what we can use to obtain our two equations. First of all, we know that the total number of people that attended that day was 275. So if I let A be adults and C be the number of children, I know that A plus C is equal to 275. That's one equation. I need a second equation. In order to obtain my second equation, I'm going to be looking at the revenue and the price. So my total revenue is $3,125. The revenue I obtained for my adult tickets was the number of adults that attended times the ticket price of 13. So 13 times A will be the price that the adults paid in total. Similarly, each child paid $7. So if I multiply $7 times the number of children, that will get me my total revenue from the children tickets. So that will be 7C. So there's my two equations. In order to solve this, I think it's going to be easiest to eliminate C, because 7 is a smaller number than 13. So I'm going to take this equation and I'm going to multiply it by 7. So I will get 7A plus 7C equals 1925. Now let's follow through like we did with the previous examples. So I've rewritten these equations, and I actually put this equation first because the coefficient for A was larger here than in this equation, and then it makes it easier when I subtract not to have negatives. So what I need to do is I need to subtract the second equation. So 13A minus 7A gives me 6A. 7C minus 7C is gone. 3,125 minus 1,925 is equal to 1,200. Now I can solve for A by dividing both sides by 6. 1,200 divided by 6 is 200. Now that I know what A is equal to, it's easy to find C. My first equation was A plus C is equal to 275. So I'm going to put 200 in for A. To solve for C, I'm going to subtract 200 from both sides. So I know that there must have been 200 adults and 75 children. If I did a quick check, 200 times 13 gives 2,600. That's the total for adult admissions. 75 times 5 is 525. That's the total brought in for children admissions. And when I add these, I will get 3,125.